Hey, it's Patty. I wanted to take a few minutes to try to condense what I spent 90 minutes rambling on about the extracellular matrix and connective tissue disorders. And please, if this starts to sound interesting to you, which it should sound for every person out there that lives with or treats connective tissue disorders, go listen to the 90 minutes. There's a lot of information in there, and I don't even tell a portion of it. It's so deep in the information that we could get into once we understand that this is an extracellular matrix dysfunction, and we can have a connective tissue stability problem because of it. So we really have to come back to what's an extracellular matrix dysfunction. And what we're talking about with connective tissue disorders is something happened to the 3D structure of this matrix. Now, with our extracellular matrix, we can have this in between space, which is very problematic for people, and the space that's commonly ignored in medicine today. Sorry, it is. And then we have these other spaces that when you put these different ingredients into the extracellular matrix, because the extracellular matrix, depending on where it is, can be composed of different amounts of collagen type 1, or here it's collagen type 4. And this is where it gets important because if you have a connective tissue disorder, you have an extracellular matrix dysfunction. That's not to say that everybody looks the same because there's so much inside the extracellular matrix. Collagen is a component, but then we have over 20 different types of collagen in the body. So, what type of collagen are we talking about? And depending on that type of collagen that you might have a genetic variation in, well, then is that collagen located densely in the extracellular matrix? Like we talk about ligaments and tendons, and there are more collagen type 1 and collagen type 5, but what if somebody has a collagen type 4 problem? And that's more of a barrier membrane problem, or collagen type, 2, and we have more of the cartilage type problem that we're seeing. So this is why it's really important to understand why it's so difficult to figure out what genetics we're talking about with connective tissue disorders like the unidentified hypermobility or hypermobile Ehlers-Danlos syndrome or hypermobility spectrum disorder is because it could be so many different things that affect the structural component of this extracellular matrix. So I'm going to come away from talking about tendons and ligaments and tell you why this concept is so important. So we do have some people that are talking about this interstitial space, right? So the interstitial space is the space in between these different components of tissue structures like fascia and muscle and things like that. So with the interstitial space, there is work done by Brian Tuckey that says like, hey, this interstitial stasis where things stop moving, we get an inflammation buildup from local trauma, things will build up, and we end up with like a trigger point response and stasis. So we're not clearing it out, and things get kind of stuck together. And then we have Tina Wang, who for our community has done some research and said, hey, this is even happening more so in those with hypermobile EDS, that the space in between the fascial layers of the iliotibial band are really not moving. They're really stuck together once you add inflammation to it. And this is where understanding the systemic component of the extracellular matrix that is more like an organ in the body itself, kind of like skin and fascia, but it's not fascia exactly. So the interstitial space of the extracellular matrix is really where homeostasis happens and communication in the entire body happens. So it's kind of like all the in-between spaces, but this is interstitium. And typically what we have is a whole bunch of stuff that happens here. We have collagen type 1, 2, 3, 5, and 11. And then we also have proteoglycans too. So those are kind of the structural stability components of the extracellular matrix where all of our cells are supposed to be moving through freely. But this is also where pathogens come and inflammatory reactions happen. And if that becomes overwhelmed, then you can have this stasis, not necessarily affecting local tissue that's sticky in between the fascial layers, but you can have this systemic response because in this space that acts like an organ, if you have a pathogen like a virus that causes inflammatory responses in one part of this interstitium of the extracellular matrix, it sends signals to the rest of the body saying, hey guys, we have a pathogen here. And you'll have different responses throughout the whole body. That is the extracellular matrix. Now, understanding that stiffness can happen probably because of this structural integrity problem, right? Like we don't have the strong scaffolding that's holding up this intracellular space or extracellular space of the interstitium. It tends to fold and collapse a little bit more. And when you add stuff into that space, like inflammation, it has a harder time of controlling it. So you're at increased risk for developing this interstitial stasis, right? Well, when you add that to spaces, we're talking kind of the interstitium as this whole body organ that was actually by Alfred Pischinger in the earlier 1900s, the first half of the century, understanding this as like a whole organ system, we end up with more systemic driven responses in interstitial changes in extracellular matrix stiffness. So it goes from being an I'm flexible problem to actually there's congestion happening and our plumbing isn't great in between these tissues. And the reason why this is so important is because, yes, it affects homeostasis. Yes, it affects overall health of the individual. But when we're talking about the extracellular matrix stiffness, this can occur around certain tissues that become more irritated and inflamed as well, including neurological tissue if things break through the blood brain barrier and our vascular structures. They can become irritated and stiff around those barriers depending on the individual, their genetics that we're talking about. What collagen is involved? Is it a proteoglycan? What might be affected? And then what have they been exposed to? And what are the other anatomical components? So it puts this whole story together of this person has multiple areas of abdominal compression because they have some collagen variants. Let's say they have collagen type 1 and they have collagen type 11, and it's hard for them to manage that that interstitial space of clearing out inflammation. So that actually becomes congested a lot easier. And if that happens, especially around that vascular tissue, it can compromise its stability and it can make it more responsive to compression that happens for any reason. But we have this stiffness that's built up. So it's going to change the structure, stability, function, and flow. Okay. It is systemic wide that it happens. Again, this whole system talks to each other. And you can have anatomical variations because of hypermobility that cause changes and shifts that feed into the compression. Yes, that's why it's never one thing. It's usually quite a few things that we have to look at. But this problem is not a tendon and ligament. We really have to change the language of this. This is a genetic component that changes the structural integrity of the extracellular matrix. That is so important to understand. And then hopefully we'll have some more research on the extracellular matrix done at some point. But to understand why this turns into like when you hit the point of progression of symptoms, right? Like that domino effect that happens. What that is that that individual has typically reached the point where they can't manage the amount of inflammation in the interstitial space, and things have become congested, and it just shuts everything down, and lots of things become dysfunctional because that's where everything happens in the body. That's where cells move through, where they communicate with each other. Inflammatory mediators are expressed. It's in this extracellular space. That is the place where dysfunction happens structurally with connective tissue disorders. So this is way more complicated than a tendon or ligament problem. And I think that we should start treating it as such and understanding that chronic inflammation that is not assisted in this population will lead to a progression of what look like anatomical problems, and they're not always that. So if you want to hear me talk about this for 90 minutes, you can go listen to the other YouTube video that I have up. That again, all the science is in there, the slides are on there. But please, let's start using some different language with this so that we understand our own bodies and validate the experiences that we are having. And also, our medical providers need to start learning this difference that's happening and really more scientifically on a cellular level, what's happening in these individuals. Thanks for listening. I tried to condense it. But go over and listen to the other video if this does sound interesting. Thanks.